everybody. Good morning. Mark Malburg from Digital Metrology. We are so stoked to have him here.
Oh, it's great to be here. Thanks.
Listen, I met him at, it was the Rottler Open House.
The Rottler Open House. You sat in the front row.
Yeah.
You're my favorite guy in the whole room.
Really?
You asked a great question. Absolutely.
I asked for a hug because you kept saying somebody's going to get a hug, and I thought this guy's got, he's man enough, a room full of men, and I forget what it was. Somebody get the right question, we get a hug or something like that.
It was whoever, somebody asked me a question, and I like to interact. I don't want to lecture.
No.
And at some point along the way, you dropped a question bomb on me that was profound. And I said, that's so good. Come on, give me a hug. And a room full of men, that kills. That's comedy.
So we hit it off.
And I didn't know you were going to come up and give me a hug afterwards. So metrology is metricology like science.
Yeah.
So metricology, measurement science.
Yeah. That passion for that,
yeah,
because you started your own business. How long is it you had your business?
My business is 25 years. Dang. I was in industry for 10 before that. I've been a surface metrologist for 35 now.
Dang.
Yeah.
You're like the man in this industry, though. I mean, no, you are. Say it, dude. It's okay.
No,
you can flex. You can flex on that.
No.
I think so.
It's such a huge privilege to do what I do. I get to go to some of the coolest places. I mean, I'm working on spaceships and smartphones and optics and lasers. And
everything has. I remember when I heard you once, you said, that even the way a screen feels or the way everything, or any product, the texture of it is important.
100%, yeah.
Right.
The surface is the thing you're going to touch, see, feel. And it's the thing that's going to make an engine work.
Yeah.
Everything comes down to something touching something.
And it's true, I'm old enough to remember when, you could literally ball on a cylinder wall and think,
yeah,
I'm good to go.
Well, and in that generation we were.
And I'd take a dial caliper and I'd say, I'm
sure.
good.
Sure. And now we're doing 3D mapping and everything else to try to get that last little bit more out of it.
Yeah.
So, not just is it round, but what kind of round? Like, are there 12 bumps or 14 bumps within the roundness, or odd lobes, which you'll never see with dial bore?
Is that where the thing does that?
Well, it's more at the ring scale. So rings can go oval and they like it. If you're out of round oval, the ring says okay. But if you're out of round with little ripples, rings aren't happy.
Yeah.
And the modeling and things that are going into that to get that last little bit of performance out of things, it's crazy.
Yeah.
I'm in a great place right now because everybody's trying to measure that last little thing that might be a lever. A piston ring can bend to my fist. I make a fist, the ring wraps around, or a gasket, anything can bend, but it can't bend to my fingers. I can't fill those gaps.
Okay.
I could fill this gap. I could, think of, bending anything.
Yeah, the ring has a gap, so it's going to do that.
Well, and also the ring is flexible. It doesn't have to be round. Now, you guys need to be round for skirt clearance on a piston and stuff, but life in general bends. Piston rings bend. It could bend and fill this.
Okay.
But it can't bend and fill that. It's too close together. So people are working in surfaces much more in the realm of curves and shapes and waves and harmonics instead of just how rough is it, how round is it.
So let me ask, what is the next phase in machinery that we need to get that type of finish and performance out of our finish? Is it a totally different machine or something like that? I mean, is there any development in that?
Well, we're at a realm right now where we don't quite know for this space. People that have infinite budgets can, try weird nuances and fund universities and things like that. So I don't think our tools are limiting us yet. It's our knowledge of what each platform might need.
I'm going to show him the shop. I don't often get it. The guy's got a PhD, so I'm a little starstruck right now. And we're going to give him a tour of the shop, and then we're going to sit down and talk surface.
Let's talk surfaces, geometry.
Surface. Yeah. Now I know everybody, not everybody, all the people that are built like me are excited and perked up. And everybody else that's not, well, sorry.
There'll be some nuggets, I'm sure.
Sorry. Well, yeah, stick around. We got some nuggets for you. Come on. So these are all working bays. We're just doing stuff on. These are more bays. So this was the original building.
How many bays total would you say if you shuffled?
25.
25.
Yeah. And so what happened was, this was the original building.
Yeah.
People would come in here,
Okay.
drop stuff off. When I say the original building, I worked for about 3 years before I put this place up, moved to 3 different places to get here. But up until last year, that's where we meet and greeted all our customers, right at that front counter.
Wow.
And then this is what you have for your guys. Got to have quality snacks. I'm serious.
Legit Cliff Bars,
You
even.
got to
generic stuff.
You got to have the quality stuff.
I see you interact with your guys. There's a lot of respect, and take care of them with the right tools, even the right snacks.
Yeah.
But give them responsibility and encouragement.
Yeah.
You can get great things out of people that way. That's that DNA piece we were talking about.
You know, man, the team. I mean, this is a pretty good sized ship. I mean, there's bigger companies for sure.
Right.
But for a little, it's a big ship, and you need the team to function.
Yeah.
Or my name's on the building. I tell these guys all this all the time. I said, all you guys get up here and walk out of here in one day, and you find out how long days last. I'm just the guy.
Right. Right.
You guys are the ones rowing the ship.
And it's cool that you recognize that, because I think that builds responsibility and ethic and drive to be better.
If you don't recognize that, you're butt stupid.
Yeah.
I think of it like, I'm a big ocean guy. I grew up in the Keys before I moved out here to Utah when I was in my 20s. But being on a boat and working on boats and things like that, you have to have, everybody's got a job.
Yeah.
The captain's just the guy that gets to point the ship where it's going to go, but it ain't going to get there.
Right, but we are winning, not the captain. We, the team is.
Yeah.
Yeah.
We gotta make that all happen.
Right. Right.
Yeah. So I'm lucky to have every guy here. What we're doing here, this is in fact, the crank's warm. He just did this. We're TIG welding that gear on. These gears are press fitted on the cranks. They're not on keyways, and there's some real problems. The Duramax is the worst one. In fact, we got a bunch of them over here. I'll show you. A keyway on a Duramax.
Yes.
Yeah, where they're just pins.
Yes.
And then we put a keyway in them.
Right.
So that's something that we do on every one of our cranks. These are probably here getting ready to either be balanced, because what we found is on every, we're just a 6-7 power stroke. I got those on my mind because we've just been doing a batch of them.
Yeah.
We go 20 over on a set of pistons on that.
Okay.
All of a sudden our dynamics are different on the crank.
Oh, right.
So that's an externally balanced engine. We want to make sure that it's still balanced to within factory with oversized pistons on it.
Yeah.
And other shops don't do that.
Well, then you've got to actually, instead of machining weight out, you got to figure out where to put weight on.
Yeah, that's exactly what we're doing.
Yeah.
And we just weld up the hole.
Yep. Okay.
We do, but that usually we don't start doing the heavy Mallory and stuff like that unless we're doing an internally balanced. Usually we can get away, find a one of our holes here.
Yes.
And we'll just weld
in an existing hole.
Weld in an existing hole.
Oh, that makes sense.
Yeah.
I'm just surprised to see this much crankshaft activity.
Well, we got a lot of motors open. So then we got then over here is our teardown and inspection.
I love a teardown video, by the way. You guys could just show those all day, and I won't get anything done. I just watch you guys tear engines down.
Really?
Oh, well, it's like opening a present. You don't know what you're going to see. How are you, man? It's good to see you.
Good to see you.
And this is Jesse.
Jesse, nice meeting you.
Without him, man, this machine shop would not run so smoothly.
Yeah.
He allows me to stay in the build room.
Yeah. Eric's a new guy here.
Eric, I'm Mark.
Mark,
nice to meet you.
We're thrilled to have him.
We sat in on one of your seminars at PRI.
Okay.
Yeah.
Perfect. Thanks.
So anyway, he's about surface finish. He developed our software, Trace Boss.
Yeah.
This is the guy. This is the PhD that made that all happen, man. So, we tear this down, and then we want to make sure that it's better.
A lot of red and black stripes going on.
Yeah, I used to have Sunnin. I had a CB, a Hone, with this sim test, wet bench, and then this is Joey's domain.
This is pretty legit nice, though. I mean, number one, lighting.
Yeah.
That's huge.
Yeah, you gotta have good lighting.
Done really well there. You guys hone crank bores?
We line hone every block.
Wow. Yeah. Wow. But that's that commitment that we're not just going to fix it, we're going to make it right.
Yeah,
it's not a Band-Aid.
Right.
It's
just because that one's the right size, that one's the right size, that one, they're all the right size. doesn't mean they're
Not lined up.
They're not lined up, and I
Right.
mean, and you can tell that, and you can fix it too.
Yeah, and I bake all these blocks at about 700 degrees.
Yeah, how long?
About an hour.
Okay,
Yeah,
so they've fully
yeah,
stabilized.
Yep,
Yep.
an hour, and then we shot peen them.
You know, we had Lake Speed in here last week,
Blake's a great guy.
and super great guy,
yeah.
and he gave us some suggestions. You're here, and I sure appreciate it. Would you be so kind to give us a nugget of something that would make us better?
Let's pull up some data if you've made some measurements in the past. If you've got something stored, let's take a look and just talk through some
Sweet.
findings. Every application is different. If you see any of Brad Lagman's material online, you know, for the drag world, depending on the fuel, everything else, he has recipes for every application, every fuel. There's not going to be a one size fits all. Yeah, let's look at this surface through the eyes of, you know, differences that different engines might need. If we look at that surface, my eyes cannot tell me where plateaus end and valleys start. Think of the extreme of icicles on a roof. You know where the roof ends and where the icicles start.
Right.
I can't tell you where the roof and the icicles meet in that surface. Now that scenario is really weird. What we find is a surface that doesn't have that distinct transition tends to break in forever. It doesn't find a happy place as easily as a surface that's clearly defined. Peaks, valleys. This surface is a little better defined on the screen here.
So point to the definition that tells you in your eye.
Well, in my eye, I see a lot of, you know, ink from the plot,
Right.
and then it turns real light, and the valleys are far apart.
Okay.
So if I were to
And
draw
this-
that, so it's super subtle stuff, but let's start out with, you know, what plateau honing is for people online that
Yeah.
are getting caught up. What we're going to try to achieve is the surface that's already broken in. It's got smooth stuff on top and valleys to carry the oil.
This is the cylinder wall,
Right.
so to speak.
Yeah, so the
Yes.
piston ring is going to be sliding around back and forth on that.
Right.
This way. Right?
Yeah.
Okay.
Yeah, we got you.
So material is here.
Yes.
Now, to make that, we're going to do something crazy rough. And then we're going to wipe out those peaks with a plateau process. So these peaks go away.
But we don't want to get this too smooth here.
Right, yeah. So there's a couple of things going on. Let's think about what makes that surface functional. We've got some goals. That surface is going to contain an explosion. So it's got to seal really well. We're literally trying to contain as much of an explosion as we can against that piston ring riding on that surface.
Right.
So we want it to be smooth generally. We don't want a whole bunch of leak paths. So this plateau part is kind of smooth for sealing and smooth for low friction. Now, one particular car, we'll say it rhymes with Addern, started down the road during development of making smoother and smoother cylinder bores. And oil consumption was good, and vacuum is good, everything is happy, until everything scuffed. So now we have to start thinking about scuffing and putting some oil in that interface, and that's where we need the valleys. So we needed to make that rough surface to give us some valleys to hold on to the oil, but still keep that smooth interface for the piston ring. That's the balancing act we have now, is how smooth. Well, if it's too smooth, we've got another problem. If it's too smooth, what if it's out of round? My ring is going to ride
now
on the peaks.
This is looking down.
Right, we're looking down, and if we have weird roundness, you know, maybe we have head bolts that are causing local distortions. So if it was perfectly smooth, these are all air gaps now, or oil gaps, or
Gaps.
gas gaps, whatever
Yeah.
it's going to go
Right.
through the gaps. So we're going to put some roughness on these peaks to give the ring. It's going to allow these areas to wear away and still kind of fill in the gaps with roughness. So the peak roughness in our plateau, this stuff here on the top, the RK and the RPK in our numbers, that's a roundness protector.
So this is important to us. So this
Yeah.
is, so in here is the
RK.
Write that down, would you?
Absolutely. We're going to pull it up on the screen here
Okay.
next to us. It's
So
not
that's our
asleep.
RK in here,
Yep.
and our
PK
PK is the very top, the P.
Right.
P.
On the screen, this pink zone at the top,
Uh-huh.
that's the height of the pink zone is kind of the average height of the peaks sticking out of the plateau. Then there's a white gap in the middle, which is our plateau zone.
And is that the RK?
That's the RK, exactly. And then the blue zone on the bottom is kind of the average-ish depth of the valleys below.
Is that the RVK?
That's the RVK. So
the RVK is the
valley,
the blue line,
yep.
and the RK is the middle.
core.
So it just kind of whipped around here.
You mentioned they're flipped around on the screen.
Yeah.
And you're talking to the guy who flipped them. So I'm going to give you a little insight there on why they're flipped.
Good.
All
Oh,
right.
okay, cool.
Okay, so they're flipped on the screen because RK is what matters. RK is that running surface, it's the break-in surface. RPK is going to go away real fast. In fact, RPK, the pink zone at the top, if you, and I'd love for you guys to, if you had a chance, assemble it, disassemble it, and see how much those peaks changed. Because RPK goes away real fast.
Well, when I do, so we'll build a motor in here, I'll throw the pistons in it and rings, do a couple of rotations, and I'll actually recheck it, and it does,
Yeah, so
you can see it really quick.
RPK is really just the fuzz at the top. I don't put a lot of effort into it
It's lit,
myself.
man, it's lit.
Can be. So that's probably dirt. You couldn't have honed that.
Right.
Your honing stone isn't going to make a
Right.
peak like that. Even this one maybe was dirt or something.
I got you.
So I don't put a lot of weight in RPK. RK is what matters. That's that surface that's going to be rubbing against the rings. It's going to break in.
The longevity.
Kind of the longevity, but it is the sliding part. PK goes away and RK is what really is the action for sliding. Now, let's go a little next level, shall we?
Do it.
All right, this is where you guys aren't yet. So I'm going to take you to new places.
Oh, man.
And we're going to use this
This
new
is Star Trek stuff.
Oh, it is. Boldly. We're going to boldly go. We're boldly going.
Okay.
So this is what I'd like you to think about, and I don't have the answer, but you guys might because you're closer to performance than I am. So I'm going to draw two surfaces. I'm going to draw this guy that looks...
Now this is a cross, so this is a cylinder,
Yes.
and this is the edge of this. This is air, and this is the material.
Right. So that's a surface that looks kind of cool. Let's look at that surface through the eyes of how much material is going to carry a load at the top and how much air is left for oil underneath. I'm not saying put numbers on it, but think of those two things right now.
Okay.
We've got load carrying at the top and air or oil underneath. I'm going to draw a different surface. How's that feel for load carrying versus lubrication?
Well, in my mind, it's more load carrying
And no lubrication.
and less lubrication.
Exactly. Now let's look at this one on the screen. We can't tell it apart, right? We don't see where load carrying ends and lubrication begins.
I'm assuming all this stuff in the blue is lubrication.
I can draw a line here and say, here's where they meet. On a surface like that, I don't really know where they meet. Where do the icicles start and where does the roof end? I can't say this is RK and this is RVK. Here I'm saying I don't know where RK ends. If I were to draw a line where plateaus end and valleys start, the best guess I would have might be way down here. I can't add valleys to that surface.
So the valleys come first.
Exactly.
And then
Yeah. We've got to start with something really rough and then come in and plateau it. So yeah, we're going to make something rough. In fact, this is where you control size. You rough it, putting the valley texture in this very rough surface.
You guys know that.
Yes.
And that's where you control size, and then it's just strokes to get finish. I just love, showing people, hey, this is what you're making, and they say, oh, I've got a knob I can turn. So for me, life is all about light bulbs. When people started seeing that as I add strokes and show it on the screen, I can see my texture changing. That's like, wow, all right, now I can be a craftsman. I'm not just pushing a button and getting an RK number.
One thing, Jesse, I see him do a lot with your software is he's always, trying to adjust the finish and stuff on the walls.
Yeah.
He'll do one hole this way, do 10 strokes with the plateau that way, see what it is, and I mean, if you look on the side of the hone, he writes all that shit down.
You're the man.
So I get
He
a
does a great job at it.
I get a new
Yeah.
engine, or we just did sleeves. This sleeve material is different than this engine. So
Right.
before I even go to my size, I'll take one bank and I'll rough these all.
Yep.
And I'll put some CBNs and go, I'll do 5 strokes on this, 10 strokes on this, see what am I coming out with.
And the picture tells you more than the numbers, right?
Right.
The numbers, like you guys have RK numbers you're shooting for, those numbers don't apply until you're finished.
Right.
So this is also worth noting for people who are getting into the game. The RK parameters, RPK, RK, RVK, those numbers are based on this curve, and it's going to try to find the flat part of the curve over here. So it's going to try to find this level part, and that becomes the white zone over here. That's the RK zone. There's a little curl up here that's pink and a little curl down here that's blue, peaks and valleys. A surface that's plateaued has all of that stuff going on in that curve. I can find the RK zone, and below that is the RVK stuff, and above that is the RPK stuff. If I start with just my semi-finish, this surface, that base hone, what do you use, like 100 or a 120?
I think they're like 80.
An 80, all right,
Yeah, I
good,
think
good.
so, yeah.
So this
Roughness.
surface doesn't have peaks and valleys yet. So if you say, well, I need to hit an RVK, I need to make sure my valleys, the blue zone, I need to make those blue valleys the right depth, we can't tell because we don't have valleys yet. The math says, I don't know what a valley is. RVK doesn't apply until we plateau. So for this case, instead of looking at RK, looking at RVK, RPK, we go to the parameter RZ. So RZ is the second one below RA over here.
We're getting deep now, man.
That's the key. That's the key. We base hone to an RZ value, and once you've got enough roughness in your base hone, with that number, we can start plateauing our way down
to getting the
to get to
valley
that
we
point.
want.
Yeah. These numbers that we've grown to love, RK, RPK, RVK, only work after plateauing. And I've seen people chase their tails. They're trying to lay down a base surface. I remember I said we're going to try to find a line here, and everything above is peaks and everything below is valleys. What if I tried to find a line here?
There's no curve.
There's no curve. There are no valleys.
Yeah.
So we're laying down a base hone surface to make valleys, but the K parameters will say, no, we don't have any valleys. It's all RK. That line says there's nothing below. This line has something below. So looking at the RKs, it's just chasing your tail until you get to a plateau. So for you guys, I'd say start thinking about, documenting for different material, different finishes you're trying to achieve. What RZ do you need in the base hone to help you land at the finish you want? And looking at the pictures is how you're going to get there again. Yeah. So I mentioned a little bit that this peak roughness up here at the top is all about break-in and hiding your roundness errors. Roundness is not what we see with the dial bore gauge. Dial bore gauge measures 2 points.
Right.
It can only see even orders. The dial bore gauge can see ovals really nicely. I deal with engine blocks that when they distort, they're torqued up, they can actually be triangular at the top. The dial bore gauge sees that as perfectly round. One side's low while the other side's high.
So we need a better machine to measure our holes.
We do, and that's kind of a holy grail right now. You may hear in the industry of the term the Incometer. It's $250,000 and they stopped making them. There's a company I'm working with that's trying to make a replacement, and it's going to be bigger and heavier and even more expensive. So it's a challenge right now. So what I want to tell you is keep using the dial bore gauge, but keep in mind that things can be going wrong. And this is really useful when you tear something down. See what the wear pattern is. Is the wear pattern, every head bolt? Is it oval? Is the wear pattern 3 scars? And then you're in a situation where maybe your dial bore gauge hid something from you. So we can only really do post-mortem effectively in terms of cost. If we were to talk about just the most simple roundness measurement in the world, something that we could put a con rod on a table, stick a probe in it, and spin it mechanically without even bringing lasers into it, roundness starts at about $15,000 to be able to get a spindle and a probe just on something tabletop.
Right, that I can take to the machine.
Right, put a piston pin in it.
Gotcha.
But to build it onto something I can drop onto the head, head deck of a block. Yeah, that's Crazy expensive stuff. I'm working with an idea right now of a 3-probe system that will find its own center based on 3 probes. We do this for crankshafts currently, because the crank pin, you know, you can't put that on a roundness gauge. But 3 probes can follow the pin as you rotate, and we can do perfect roundness with 3 probes. It's never been done on an ID, but it's a super hard challenge. And the system I'm talking about replacing the Incometer, it's a laser-based system. That's why I'm kind of half laughing, but it's hundreds of thousands of dollars.
Okay. I like tools though.
Yeah, you like tools.
Well, I've heard that NASCAR teams even will run the coolant, you know, they'll run hot hone their block. Is that true, or is that just? It
is. Now, here's the other side of that. Hot honing is going to introduce block level distortions, which are often oval. The ring may not care, because piston rings don't mind oval. Take a coffee can, you can squish it oval real easily. Try to squish it with, 12 points, that's hard. 2 points is easy. So we can squish things into ovals. So hot honing might have a slight benefit, but some of the experience in OEM worlds is hot doesn't matter because it's only oval. Now that you guys are seeing surfaces, here are the levers we can turn. So to say this is going to be a diesel, this is going to be gas, this is going to be, tractor, whatever you're into, these are some things to watch for. One thing we can watch is just strictly how deep do we plateau. This surface is going to have more load carrying and less oil. Same valleys, how much plateau do we need for break-in? You can see that in your pictures. I don't know which engines you make that might need this, this, or this. Or we could be in a realm where we just plain need a lot more valleys. Well, this is the stuff that Lake is talking about in drag racing.
Right.
But when I see this surface compared to, again, worldwide, China, India, US, Detroit, everywhere, I'm seeing surfaces with less valleys than this. So maybe messing around with the concentration of the valley stone, the density of abrasive, it's diamond with glue, more glue, less diamond. So a surface that generally looks like that, where maybe you see 10 valleys instead of 20, but we still have deep valleys. In production engines in, let's say, around Detroit in diesel, and those people doing diesel, I might see a little smoother plateau. They're using massive, big, expensive hones that might produce better geometry. So maybe you need a little more roughness in the peaks to allow you guys to break into something that's going to be awesome. Because they're literally spending millions and millions of dollars on hones. So we can get there by craftsmanship, where they get there by brute force money. So there's a number that I use that tells me kind of durability, how much surface area. It's RMQ. Now the surface has to be pretty well plateaued for it to calculate. So RMQ may not even show up on your screen sometimes. That's 68. This guy over here is 80. And you can look at the two surfaces and say, this only has 68% material.
That looks a lot thicker in the white area than this does.
Yeah. So this is how much material is going to carry the load. 68% of that surface is going to carry the load. The rest is air and oil and everything else. This one, we've got 80% metal carrying a load. 90 is pretty typical in production engines. So a few less valleys is what I see across the board.
So our abrasives have got not enough glue in them, and
a little too much stone.
Stone, yeah.
Maybe. Or you can mess it with pressure. Pressure can get you there, push harder. Huge props. Carl actually wrote it. I did a lot of talking and helped with figures, but Carl did the work. So Carl, if you're out there, I love you. Great picture to remind people what we're actually doing. This is what you're doing. So these two surfaces, each of them has kind of their own distribution of points. They've got a lot of points in the middle and a few out at the edges. So that little histogram is kind of how far the points are spread out in the surface. There's a math trick for looking at two distributions, and it turns them into two lines. And where the two lines meet is mathematically where peaks meet valleys. It's saying that the plateaus are aligned and the valleys are aligned, and that's right here on the screen.
Oh, we got an El Camino running.
So there's the plateau part, there's the valley part, and there's where they intersect. But this is an example of how that curve can look very different. So that's material probability. You've got guys messing with it right now that are trying to take their honing next level.
Really, what you're trying to achieve is as little break-in as possible.
100%,
and,
yes.
And just be almost out the box broken in.
Yes.
Right?
Yeah. Yeah, we want that.
Why wouldn't you want it? Because then your rings are just brand new. You know, they're not doing the work.
Because I mean, old school was
Yeah.
you're running it to break it in.
Yeah.
Right. Well, yeah.
You're running it to plateau.
100%. Yes. You get in your new car in the 1980s and you plateau it for them.
Yeah.
Yeah.
But then that just chews up your rings.
All the debris goes everywhere in the engine. Yeah. That was a deep dive, guys. Thanks for staying
Man,
with me.
that was awesome. Thank you.
Thank you. Thank you.
Thank you.